All right, let's take a look at segment addition postulate. Segment addition postulate is a rule that states that if you have a segment AB and you add that to a segment BC, in the end you'll end up with a segment that goes from A all the way to C. So we're just taking segment AB plus BC equals AC. It's pretty easy to see when we put in numbers. Let's say that segment AB is 5 inches and segment BC is 3 inches. So 5 inches plus 3 inches tells me that segment AC would be 8 inches. Pretty basic, but it's a concept that we're going to build on quite a bit. So let's take a look at some different segments. Some of them we're going to use segment addition postulate. Some of them we're going to use the idea of a midpoint. So let's just take a second really quick and look at a midpoint segment idea. Let's say that we have this segment AC and we place a point on it so that that point is exactly in the middle. So we could say that segment AB is congruent to segment BC. So if segment AB were 4 units, segment BC would also be 4 units. And we know that segment AC would be 2 4-unit segments put together, or 8 units. Now notice that I'm not putting that little segment bar above all of these. When you start working with segments, we get a little bit lazy. We don't always put the bar above. That's fine. It's kind of understood that if you have 2 capital letters together, you're talking about a segment. So we can be a little bit lax and not put that bar across the top. All right, so let's move this out of our way and let's look at some segment addition postulate examples. All right, we'll start with this segment here. We have E, F, and G as points on this segment. Let's say that we know that EG, this whole length, is 45 units. And we know that EF, this length right here, is 15x. And we know, I need another color here. We know that FG is 4x plus 7. So what we know is that EF plus FG equals EG. So we can go ahead and plug in the values that represent each of those segments and solve for x, plug it back in, and find the length of both EF and FG. So EF is 15x, FG is 4x plus 7, and EG is 45. We can combine like terms. 15x plus 4x is 19x. Bring down the plus 7, that equals 45. Subtract 7 from both sides. We get 19x equals 38. Divide both sides by 19. And we know that x is 2. So we can take that value and plug it back in. So EF is 15x So that would be 15 times 2, or 30. And we know that FG is 4x plus 7. So 8 plus 7 is 15. Now to find EF, we could have easily gone, we know that 45 is the whole length. We've used 30 units for EF, so there's only 15 units left for FG. That's totally fine. It works great. So let's look at an example of the midpoint idea. Okay, so now we're going to be working with a midpoint. So here's our diagram. We have W, A, and X. And we know that A is the midpoint, so we know that WA is exactly the same length as AX. So let's just write a little statement that we know. We know that WA is the same as AX. But we also know that it takes 2 of the short segments, WA or AX, to equal the full thing of WX. Both of these are going to be very helpful statements. So let's take a look at some information here. Let's say that we know that WA is 3x, and we know that AX is 5x minus 6. Now, on another example, this would not be enough information, but since we're dealing with midpoint and we know that we have congruent segments, this is all we need, because we have this statement here, WA is congruent to AX. So we can take what WA is worth and set that equal to what AX is worth and solve for X. So if we subtract 5x from both sides, we would get a negative 2x equals negative 6. Divide both sides by negative 2, and we know that x is 3. So when we plug that information in, 3 times 3 is 9. So WA is 9. And let's just double check. AX should be 9 as well. 5 times 3 is 15, and 15 minus 6 is also 9. So we did great. It worked really well. Let's take a look at an example where we might have this scenario, 2WA equals WX. Let's say that we were given the WA value and the WX value. We would be able to use this expression and take 2 times the short to equal the long, and we would still be able to solve for the missing information.